This problem is the 40 kilogram pendulum has its mass center as G and radius of gyration about point G of kg is equal to 300 millimeter, and it is relates from length when theta is become 0 degree. Okay, determine its angular velocity at the instant when theta equal to 90 degrees. Okay, and we know that the spring AB is equal to the spring constant is equal to 300 Newton per meter, and is unstretched when theta is equal to 0. Okay, so according to this problem, we may have to draw the picture like this. Okay, so when the problem gives us that when theta is become 0, spring is unstretched. Okay, so when we consider this, when theta is 0, okay, the center point A here, it should be 0.45. Okay, and this the overall is 0.6. So then it means that the unstretched length of spring it should be 0.15. Okay, and at the final position, when theta is become 90 degree, okay, so what happened to the deformed length of the beam? It should be what? It is 0.35, it is 0.1, so overall it should be 0.45. Okay, and it should be 0.6. So the total length it should be 0.6 squared plus 0.45 squared, and square root of this we obtain the deformed length of spring at the final position is become 0.75 meter. Okay, and if we consider this problem is just about the motion of the pendulum is the rotation about a fixed axis. So it has actually rotation. Okay, and it's rotated about point O, and we have to determine IO. And IO is equal to IG plus MR squared. Okay, and IG is equal to what for this case? The problem is already give us that the radius of gyration for this mass is equal to 300 millimeter. So from radius of gyration, we can determine for the mass moment of inertia is equal to mkg squared. Okay, and we have to use parallel axis theorem to transfer the to determine the inertia about point O, that is equal to Ig plus mr squared. M is 40 and r now is equal to 0.35. Okay, so then we have IO is equal to 8.5 kilogram meter square. Okay, we apply the conservation of energy for this system because this is the conservative system. It's composed of just only the gravity force and spring force, elastic force. That is both conservative force. So after we consider this, at the first position, we set the datum here, the first one, and it is second one. Okay, so for the first one, we set the data at the first position, and we found out when for the case of conservation of energy, at the first position, it should be a half IO omega OA squared plus mgh1. Okay, and this is kinetic energy at the final position, that is a half IO omega OA as a final position squared plus the potential energy. This is the final position is become the potential energy due to the gravity and due to the spring, because the spring is has the set length already. But at the first, the spring is unstretched, so then it means that it has no potential energy due to the spring. Okay, let's back to consider the potential energy. Okay, potential energy of due to gravity at the first position is become 0 because it's along the data. Okay, but for the final position, this is the minus 137.34 Joule. The negative signs mean that the final position is below the data, so then the potential energy due to gravity should be negative. And when theta is become 90 degree, so then we can determine for the stud length of the spring, that is we found out is equal to 0.5. Sorry, is equal to 0.75 meter. Okay, and this means that the stretching length of spring is equal to 0.75 minus the unstuck length. That is we found out the stretching of the spring is become 0.6 meter. So then it means that the potential energy of the spring at the final position is become this value, the half K delta S squared, it is become 54 Joule. Okay, and we know that at the first position, the spring is unstretched. So then it means that the spring, the potential energy of the spring at the first position is become 0. And after that, we substitute into the conservation of energy. Okay, and we consider the kinetic energy at the first position is released from rays. So then the kinetic energy is become 0, and at the final position, because it has actually the rotation about 0.0, so then it had a kinetic energy due to the rotation only, that is equal to a half I-O omega OA squared. Okay, so we keep this equation, and after that we substitute into this equation, and then we can solve for omega OA that is equal to 4.4 radian per second clockwise. Sorry, clockwise. Okay, that is complete this problem.